All right, moving on to some sort of special cases with ratios. For example, what do you do when you're simplifying ratios that have mixed numbers in them? So what you want to do is the same thing you would have done with fractions where you have those mixed numbers and fractions. So we're going to convert the mixed numbers to improper fractions. That's going to give you complex fractions, right? Those fractions of fractions. And then you can write a ratio in the lowest terms. So for example, here we have Lauren sank a 22.5-foot putt and Carrie sank a 30-foot putt. We want to know the ratio of the two distances. So we've got 22.5 feet over 30 feet. You'll notice right away those feet are going to cancel out. We're going to convert our mixed number there to an improper fraction. So 22.5 is the same thing as 45 over 2 when you do the boomerang. And so now we've got 45 over 2 over 30. So here we've got our complex fraction. So we're going to express that with a division sign like they've done in the next step there. So that's the same thing as 45 over 2 divided by 30 over 1. Now that we have it like that, we can flip and multiply and then do some cross simplification to arrive at our simplified answer. All right, let's do one of our own. So we've got the diameter of a 20-ounce bottle is 2.8 inches, and the diameter of a 2-liter bottle is 5.25 inches. We're asked to express the ratio of the two diameters as a ratio of whole numbers. So the two diameters here, so the first one is 2.8 inches, and the second one is 5.25 inches. So this time we have decimals. Well, let's start right off the bat. We can cancel out those inches. And then how are we going to deal with our decimals? Well, think of how you would say these numbers in word form. So not just 2.8, which I tend to do, but the correct way to say 2.8 would be 2 8/10. And so we're going to rewrite this number then as 2 8/10. And that is over 5 25 hundredths. Okay, now we could simplify those fractions right now, or we could simplify them later. I'm tempted to simplify them right now because I know it'll make my numbers smaller that I have to deal with. So I can see I can divide both of those fractions on top by 2. And these bottom ones I can divide by 25. So let's do that first, because that's going to give us 2 4/5 over 5 1/4. And some of you might have seen that 25 over 100 as 1/4 right away, just thinking about money, because if you have $1, that's 100 cents. A quarter of a dollar is a quarter, which is 25 cents. Okay, so we're left here with some mixed numbers. So now let's convert those mixed numbers to improper fractions. So we're going to use the boomerang. So we've got 5 times 2 gives us 10 plus another 4 gives us 14. So we've got 14 over 5, and that is over. So now we want this bottom mixed number to be an improper fraction. So 4 times 5 is 20 plus 1 gives us 21 over 4. Let's use the division symbol on this now. So this is the same as 14 over 5 divided by 21 over 4. And then remember, we can change that division sign to a multiplication sign as long as we flip that second number. So let's flip that second number, take the reciprocal of it, in other words. There we go. And now we're just doing a straight multiplication of fractions. So you can do top times top over bottom times bottom. Optional step first is we could do some cross simplification, which I would like to do here because I can see that 14 and 21 are both divisible by 7. So let's divide each of those by 7. You can always divide whatever you want out of a top number, a number on the top on the numerator, as long as you also divide it out of a numerator on the bottom. So it doesn't matter if it belongs to the same fraction or different fractions. When you're multiplying fractions together, you can always do that cross simplification step. So here I'm going to take this 14, divide by 7 to get 2. And I'll take this 21 and divide by 7 to get 3. And I don't see anything else I can divide out of the top and bottom here. So let's go ahead and do the multiplication then. So I've got 2 times 4 gives me 8 over 5 times 3 gives me 15. So my answer here then is 8 over 15. Okay, one more for you with mixed numbers. So go ahead and pause this video and see if you can get the simplified ratio of these two numbers. All right, and let's try this one together. So we have 2 people jogging. The first one jogged 3.5 miles. And Yi jogged 4.25 miles. So right off the bat, we see we have the same units, so we can get rid of those from our ratio. Now let's convert to improper fractions. So we're going to have 7 over 2 over 17 over 4. And let's rewrite that with the division symbol. Okay, now I know I can flip and multiply. I like to do that down below. So I'm going to flip and multiply. So that's multiplied by 4 over 17. And I can see I can cross simplify here because I can divide a 2 out of the top and bottom. So I'm going to go ahead and do that. And that's going to leave me with 14 over 17. All right. One more thing to note, sometimes you will have 2 measures of the same thing. In this next example, we have 2 measures of time, but they're in different units. So it has Joe took 2 hours to complete his final exam, and Jamie finished hers in 75 minutes. We want to compare the 2 in a ratio. So 2 hours, I'll write it over here. So 2 hours over 75 minutes. Well, we can't cancel those units out right now because they're different. But we know for every hour, we have 60 minutes. So we can convert that 2 hours into 120 minutes. And now we can cancel those minutes out and express that as a ratio comparing minutes to minutes, just like you could compare apples to apples. So if you're ever given a situation where you have, you're expressing ratios of time, for example, where you have one thing in hours and one in minutes, you'll want to rewrite it so that you have the same units, and then you're able to cancel those units. Once we cancel those units here, we have 120 over 75. And then I would have to figure out the GCF over here for those two, because I don't see right away what the GCF is there. So let's do that. Oops, 3 and 5. Okay, so there's my prime factorization for 120. Let's do 75 now. And then let's see what they have in common. So what do the prime factorizations have in common? We've got a 5 and we've got a 3. So our GCF here then is 3 times 5, which is 15. So we would divide the top and bottom here by 15, and that will give us our answer of 8 over 5.